Okay, so I'm interested in how ChatGPT is going and how it would go working through a introductory programming course exam. This is a university level course. It's called Object-Oriented Programming. It is actually the university's second Java course because we have an even more basic Java course to start with that assumes no prior knowledge of programming. So the students come to our university with very low entry um, results, achievements, and we actually assume they've done no prior programming at all. And we get a lot of students who have done no prior programming, even in the well into the 21st century. We're getting students that haven't done any programming at school, which is amazing to me because I did computer programming at school in the 80s, so very early 80s. So it's astounding that students are still getting through school without doing any programming. But there you are. We've got students from all different backgrounds, all different levels. They might have left school in year 10 and gone to work and then come back to university as mature age students. They could be international students. A lot of our students are international students with varying levels of education and that sort of thing. So this course here is the second Java course, but it carries on from the first Java course, which is extremely basic. It's what is a field, what is a bit of memory, what is a CPU, what is RAM, that sort of basic stuff in the first course. So this is the second Java course, and in here they're still developing console programs for a fairly large part of the course, and then move on to GUI applications about halfway through the course. So very basic stuff. In the prior course, they do file I/O, but only in passing. In this course here, we cover file I/O in more depth, and students are expected to be able to write their own file I/O to save class data and all that sort of stuff. So that's where we are. So we're object-oriented programming, the second Java course at university level. But like I say, the first Java course is really there for students who have never done any programming before. So this is a sample exam, and we sort of try and get students to simulate doing a real exam. So we get them to write all their code on paper when they're working through the exam because they're still writing code on paper in the real exam. Okay, so get them to treat it like a real exam and write their answers out on paper. And there's two parts to the examination. Part A is short answers, and it's worth 20 marks. Part B is worth 45 marks. And students can enter any 9 questions in this part. So there might be more than 9 questions, and they answer just 9. Okay, this is sort of on a level with the real exam, but it's actually quite a bit easier. I always make my sample exams a lot harder than the real exam, so students can never say to me, "Oh, the real exam was harder than the sample exam." This exam is actually a fairly, a little bit simpler than what the final exam was. Okay, so this isn't the way I set things at all. But anyway, that's the sample exam I've got. Okay, so there's two parts, part A and part B. Part A is short answers, part B is programming, actually writing code or generating the output of a program or that sort of thing. A bit more involved in programming stuff. So like I said, this is a Java programming course. And so let's move on to part 1, question 1. Part A, question 1, abstract class versus concrete class. Okay, so let's copy that into ChatGPT. And just so ChatGPT's got a flying start here, let's just add a little bit at the front here. In the Java programming. Okay, so I'll just that little bit at the front there, just to make sure ChatGPT knows we're talking about Java. And I've got it there answering abstract class versus concrete class. Let's see what answer ChatGPT generates. Okay, and we'll walk through. So it's generating quite a bit of stuff here. Just one short question. That's okay. And let's just walk through what it's generated. So in Java, abstract classes and concrete classes or regular classes are two types of classes that serve different purposes. That's very true. Abstract class is a class that cannot be instantiated. That's true on its own and must be subclassed by other classes in order to be used. That's correct. It is declared using the abstract keyword, so it's public abstract class. Yes, that's correct. It can have both abstract and non-abstract concrete methods. That's very true. Abstract methods in an abstract class have no implementation and are meant to be overridden by the subclasses. That's very true. Subclasses of all abstract classes must provide implementations for all the abstract methods or must be declared abstract themselves. That's very true. Abstract classes can have field variables, constructors, and regular methods like concrete classes. That's true. And abstract classes can be used as a common base for multiple classes, providing a common interface or behavior for those subclasses. That's all absolutely correct. What ChatGPT's generated there is all correct and would all be an excellent answer. A concrete class is a class that can be instantiated on its own and can be used to create class objects. That's true. It provides implementation for all its methods, including abstract and non-abstract methods. Concrete classes can be extended by other classes, and they can also implement interfaces. Concrete classes can be used to create objects directly and can have their own data methods and behavior methods. So that's a repeat of what that first point there is. So there's a little bit of repetition going on, but overall I'd give this answer, without reading further, I would give it full marks already. Okay. So it said what abstract classes are here, and then it said what concrete classes are here. Here's an example of an abstract and a concrete class. So this is the abstract class, and it's got an abstract method there. Okay, and there's an example of a class creating a concrete version of that earlier class. So it extends the animal class, and we're providing implementation for the make sound method, and then a main method there. So there's our concrete class. There's our abstract class. This just happens to be a concrete class. It's built on top of an abstract class. That's quite okay. So overall, I would give that answer full marks. So while an abstract class can have abstract methods, concrete classes must provide implementation for all methods. Abstract classes can be used to define common behavior and provide common interface for related classes, while concrete classes can be used to create objects directly and provide complete implementation of methods for those class objects. So that's a nice little summary there right at the end, which is absolutely correct. So full marks, 10 out of 10 for that question. Let's just try rewording the question slightly. So compare and contrast abstract and concrete. This is one thing that students tend to have problems with, especially early on in the course. Compare and contrast. When a question says that, it wants you to say abstract classes are this while concrete classes are that. Abstract classes do this while concrete classes do that. It wants you to compare and contrast. Okay, so it doesn't want you to write 1,000 words on abstract classes and then 1,000 words on concrete classes. It wants you to compare and contrast with everything you say. Okay, so here we go again. And this is a nice extra question I like doing with students. Okay, so we're getting quite a long answer there. And we won't read it all on this video, but abstract classes provide a way to define common behavior or provide a common interface for related classes, while concrete classes are used to create objects. Absolutely correct. Let's just read the first few points up here. Two types of classes. Instantiation. Abstract classes cannot be instantiated on their own, but must be subclassed by other classes, while concrete classes can be directly instantiated to create objects. Absolutely correct. Keyword. So that's one difference. This is another difference. Keyword. Abstract classes are declared using abstract, concrete classes aren't. Method implementation. Abstract classes can have abstract methods. Concrete classes cannot have abstract methods. Perfect. Subclassing. Subclasses of an abstract class must provide implementations for all abstract methods. In contrast, subclasses of a concrete class can inherit all methods and override those if they want to. Yep. And so on. But again, from what I've seen so far, this is an excellent answer. I would have no problem at all giving this full marks in an exam. Okay. So that's question 1, which is worth 2 marks. So not a lot of work on the exam. It's worth 2 marks out of 20 for part A. The exam overall is worth 65 marks. Okay, so let's see how ChatGPT goes with question 2 in part A. So Java language allows implementation of multiple interfaces by one class. Okay, so let's highlight that and copy that into ChatGPT and see what it says. And we'll scroll down. Okay, so yes, that's correct. Java allows a class to implement multiple interfaces, which is known as multiple inheritance of interfaces. In Java, a class can implement any number of interfaces, providing a way to define multiple contracts or behaviors or templates of a class. Yes, exactly. Okay, to implement multiple interfaces in Java, use the implements keyword followed by a comma separate list of classes. Perfect. Okay, and that even gives you an example there. Okay, so again, I would have no problems giving that answer there full marks. Just those first two paragraphs needed. Don't need the example in an exam. Just those first two paragraphs there would answer it perfectly. Full marks. Okay, let's just change things slightly and pretend we're doing in Java a class can inherit from multiple classes. So here we're talking about inheritance, not interfaces. So in Java, you can have any number of interfaces you like for a class, 0, 1, or many. In Java, you can only have one parent class, so you can't have multiple classes. Let's just make sure ChatGPT knows that. I'll scroll down again to the end. Oops, let's do it again. Okay, so I had to start a new chat to get around that problem. But I got there in the end. In Java, a class can inherit from multiple classes, which of course is false. That's false in Java. True in C++ and C and other languages, but definitely false in Java. And what does ChatGPT say? Actually, in Java, a class can inherit from one superclass, which is known as a single inheritance. Java does not support multiple inheritance, which is a feature where a class can inherit from more than one superclass. That just that paragraph alone is full marks. No need for all of this stuff. This is all extra stuff that ChatGPT said to explain the answer, which is great. But in an exam, that little single paragraph there would give you full marks. Of course, if you're not sure of things, it's always good to give an example. But that's nice and clear. I don't need to read any of this really. I have only one immediate parent class. That's true. You can have multiple classes in the chain of hierarchies, but only one parent per class, maximum one parent, and so on. So yeah, I'm happy with that. So that's full marks. So that's the sort of questions you get in Part A of the exam. And this sample exam's been very lazy. It's only provided you 2 questions, and it said questions 3 to 10 are similar. And we'd make up questions in class to fill that in when students are working through the practice exam or sample exam. Okay, and get students to work through those. And so let's move on to Part B now. We're going to do some actual programming. Okay, so Part B, question 1. The following code defines a person class in a file named person.java. There's a person class there. There's 2 private data fields. And then there's a parameterized constructor which takes in a name and an age, a toString method, and that's all. So there's just 2 methods inside the class here, the data class. There's a person constructor or parameterized constructor and a toString method. That's all there are. No setters, no getters, nothing like that. There could be as well, but they're not here. So that's it. You are defined. Your tasks are to define 2 set methods or 2 mutator methods for the person class, to define 2 getter methods or accessor methods for the person class. So you're going to be filling in extra methods here, getters and setters, or mutators and accessors. To define a method called isAdult that will return true if a person's age is greater than 18. So greater than 18, not 18 or greater, but greater than 18. And to create a person tester Java class, which helps you instantiate a person and calls the toString method. assume person.tester.java and person.java are two separate files. So let's just copy and paste all of that into ChatGPT. Whoops. We'll paste all of this into ChatGPT and see what it says. Okay, I'm not sure how it's going to go here. So I'll paste all of that in. ChatGPT has been having problems. I've had to regen a lot, so looks like it's stalled here. Usually it answers a lot quicker than this. I might go new chat. Oh, no, here we go. Okay, so let's review the code that's been generated. Okay, so it wanted us to add, the question wanted us to add the mutator methods, in other words, the setters. And we've got set name, which takes in a string and updates the class field name with the string passed in. And we've got the set age there, which takes in an age or an integer and sets the age equal to that integer passed in. We're not doing any validation. We didn't say to do any validation, so that's perfectly fine. And we've got the getters or the accessor methods. Get name returns the name, get age returns the age. Both public up here. So everything's perfect so far. And the other thing was to create an object with the name of Johnson and demonstrate the methods being called. So person equals new person, Johnson with an age of 35. And we're printing out the person.toString. Okay, so that's printing out to the screen. So that's our person tester class. That's our person class. Okay, and that's 4 marks. I've got no problem at all providing 4 marks for that. Of course, in the exam, the students would have to write this part again. They'd never have to write the code they've already been given again. So the toString wouldn't have to write the toString as well. All they need to do is write the 4 methods: set age, set name, set age, get name, get age. Just to provide those, and then the full code here. So I've got no problem at all giving that 4 marks. That's an excellent answer and answers the question perfectly. So question 2 is another programming question worth 8 marks. This is 8 marks out of 65. Like question 1 was 8 marks. And this one's to do with very simple inheritance. So the following Java code demonstrates the concept of inheritance, where 2 subclasses, salary employee and hourly employee, inherit the properties and methods from the superclass employee. Your tasks are: write the missing implementation codes for constructors of salary employee and hourly employee classes. So fill in the missing code for the constructors, and what would have been output. What would have been the output produced by the program demo inheritance if this code executed correctly? Okay, so here's the employee class. Two private data fields there. Parameterized constructor, a mutator for set name, and a toString method. Salary employee has its own parameterized constructor, and it has this salary field. Get salary, set salary. We're going to fill in the missing code here in the constructor. Okay, so a couple of lines of code there missing that we need to fill in. All the rest of the class is complete. The toString method's all complete. And the hourly employee extends employee. And again, we've got some data fields there. A parameterized constructor, some missing lines of code here, 3 or 4 missing lines of code. Set hourly pay, set hours worked, get hourly pay, get hours worked, and a toString method. So all pretty basic stuff. And then we've got the demo inheritance class here, which creates an object of each type, hourly employee and salary employee, and calls a toString method for each object implicitly. Okay, so we're creating 2 objects and then calling a toString method. We're not calling the setters or the mutator methods directly, and the toString method there is calling the oh no, it's not calling the accessor methods either. So okay, I thought it might call the accessors. No. Okay, so pretty basic stuff really. It's a few lines of code in 2 constructors and then saying what's the output of the program. Okay, So this question here is fairly simple. It should be bread and butter for all students in the course. They should have written classes like these many times during term, and going back to the first assignment and week 2 of term, or week 3 of term anyway. Okay, so let's copy and paste all that in to ChatGPT and see what it says. So we'll paste all the code we're given in, paste it into ChatGPT, and see what it says. Okay, so righto. So sure, here's the updated code with the missing implementation. I probably should have started a new chat. Okay, so we've got our employee constructor there. This.emp name equals emp name. That's fine. This.emp social security number equals emp social security number. So we're setting in the class field. Emp name with this.emp name, and emp name on its own is a local field. So that's perfectly correct. And then we've got the constructor for salaried employee. We're calling the superclass constructor with the data it knows about, the employee's name and employee social security number. That's perfectly correct. And in here, we're just setting the salary for the local class, the salaried employee. This salary is that salary, and salary on its own is the salary passed in, which is over here somewhere. Okay, so that's perfectly fine. And down here with the other hourly employee class, we're passing the superclass data up to the superclass and just setting the data that we know about here locally, which is absolutely correct. Okay, so I've got no problem at all with the code here. I've certainly got a problem with that though. What is the output of the program? It would be a formatted string. That's nowhere near detailed enough. I want to see the output of the program. So let's ask it again. What is the output of this program? Okay, perfect. Okay, no, that's perfectly fine. Yep, so we've got the name and the social security number. It's an hourly employee. The rate's $10.50. They've worked 40 hours, and name, social security number. They're a salaried employee. They get $800 per week or whatever it is. So that's fine. Okay, that wasn't good enough. That would have been, loss of marks. But this here is perfect. Okay, so I'm very happy with that. That's full marks again for that answer. Thank you, ChatGPT. Okay, so draw the UML diagram with respect to the employee and its subclasses, which were mentioned above. Okay, so it's asking for a UML class diagram. It doesn't say UML class diagram, but that's clearly what the question's asking for with respect to the classes employee and its subclasses. Okay, so let's paste that into mentioned in the above. Okay, I'll leave question number 2 out because we didn't actually give ChatGPT the question number in the above question. I'll just paste that in, copy and paste that. And I'm not sure if ChatGPT can do diagrams. We'll find out. Oh, wow. Okay. Nice. Okay, so here's the UML diagram for the classes employee, salary employee, and hourly employee based on the code provided. So employee's got the 2 private fields, employee name and employee social security number, and they're both strings and they're both private, so the minus signs are correct. It's got the employee parameterized constructor, which takes in those 2 fields, which is correct. That's a public method. We've got the set name and the toString method. The set name takes in a string and returns nothing, so it's void. and the two-string method returns a string, and they're both public. That's absolutely correct. Full marks there. And then the salaried employee inherits from this employee class, and it's got the salary field there, which is a double, and it's private data field, so it's negative. That's perfectly correct. We've got the salaried employee parameterized constructor, which takes in this employee name, the social security number, and the salary, which is a double, and it's a public method. That's perfect. Get salary and set salary. Get salary returns the salary, which is a double. Set salary takes in a salary double value and returns void. Has no return, so it's void. And it's got a two-string method, which is returns a string, and they're all public methods. So that's full marks so far. Hourly employee doesn't inherit from salaried employee. I think there's something wrong here with the diagram. I think this arrow is meant to go back up to the top here. Okay, don't forget we're dealing with an ASCII diagram here. Okay, so I think this is meant to go back up to employee, not to salaried employee. That would be completely wrong. So the hourly employee here has got the two private fields, hourly pay and hours worked. They're both private, they're both doubles, that's perfect. Hourly employee constructor takes in a name and a social security number, and also the hourly pay and the hours worked. That's absolutely correct. It's a public method. Set hourly pay takes in a hourly pay and doesn't return anything, so it's void. That's correct. Public method. Set hours worked takes in the hours worked and doesn't return anything, so it's void, and it's public method. That's absolutely correct. Get hourly pay, so the two mutator methods. We've got the two mutators here, and then we've got the two accessor methods. Get hourly pay and get hours worked. Both return a double, and they're both public, so that's correct. And two string returns a string, and it's public. So this is correct so far. It's just I'd want to see that arrow there pointing to the employee class. Again, this is a diagram generated by ChatGPT, and I'm assuming it's wants to be wider, but it maybe couldn't do it wider, or maybe there's tabs missing or spaces missing or something. Okay, but that arrow they should definitely point to this class, not this class. Okay, the employee class is a subclass, and the salary employee and hourly classes are subclasses that inherit from the employee class. Okay, so it's filled in the missing details there that I was worried about, and it's told me that the employee class has the two subclasses that inherit from it. So based on that there, I'm happy to give that full marks. Okay, and then it just describes things here. The salary employee extends employee class. It has a constructor. Yep. The hourly employee class also extends. Yep. So it's filling in the right details here. The diagram wasn't quite correct. The arrow didn't go to employee, but it's definitely explained it here, where it's saying it definitely should go to employee. So again, that's full marks. I'll give this full marks. No worries at all. Okay. So question 4 was 6 marks out of 65. Identify the Java x.swing components from the following GUI. Explain how the layout managers can be used for this GUI. Note, the Java x.swing components must be written using the correct uppercase and lowercase letters. Same class names as Java, as defined in Java x.swing. Okay, so what it's saying there is, for example, we've got a J label here, and that's uppercase J, uppercase L, lowercase able. So J label is the swing component. So all the swing components have got J's in front. It's got to be uppercase J, uppercase L. So let's identify the components first. And I'm not sure if ChatGPT can take in diagrams, but let's see what it can do. And let's just do that for now. We'll do that part. In fact, let's make that a separate. We'll do it this way. So we do the swing part first, and then we'll do the how layout managers can be used, the next part. Okay, so I've started a new conversation here, so and I cannot paste. Yeah, so I cannot paste images in here. So it's not an image processor yet, but hey, it's early days, isn't it? So if I try and paste the image, I can't do it. Okay, but it has told me what all the images are. What all the components are. JFrame for the window title, which is that's a JFrame title. We've got etched borders and J labels and J checkboxes and J radio buttons and a J text area over here and J buttons down the bottom. Okay, so it's told me all the components. I cannot paste anything yet showing those. You can't paste images. I could maybe try and do an ASCII representation of that, where I put square brackets to indicate a checkbox or something. But I'm not going to worry. It's ChatGPT can't do images yet, and I'm happy with that. Let's just look at the next part. So, explain how layout managers can be used. We might as well get it to see if it can answer that. Yeah. Okay. So, flow layout, yes. Of course, this is an answer we're looking for here. We wanted to list the GUI components that were actually used. And we wanted to say that, down here we're using the southern area of a border layout with a grid panel there, a grid set out with 1 row, 2 columns to get the buttons in each of those. And then we had another grid layout here in the center area of a border layout panel. And this side here had a 1 row, 2 column grid where we put the first panel containing those components and the second panel. That's what we sort of think we're looking at, how layout managers can be used to build this interface. But because we couldn't paste the image into ChatGPT, it's just given us a generic answer, which I've got to say is excellent, an excellent answer, but it's not the answer we're looking for. So again, I couldn't really answer that question because we can't paste it in images. So fair enough there. Okay, so question 5, also worth 6 marks out of 65. Insert the missing lines of code in the following Java program. So we've got some imports at the top here, JavaX swing, JButton, JFrame. We're missing 2 imports here for the event something. There's something missing here. Complete the 2 missing lines of code. We've got a class play listener, implements action listener. So whenever this action listener is fired off, output will appear in the console screen. Play is selected, so that message here will appear in the console output. And then we've got a public class play tester, extends JFrame. We've got a single button, JButton BT, a constructor. JButton BT equals new JButton start play. Goodness me. So we've got 2 objects called JButton anyway. I'm not going to deal with the errors or the issues. It's bad code, but anyway. We're adding the button to our user interface. By default, for a JFrame, that would have a border layout. So we're going to have one big button in the center of our screen, which takes up the whole user interface. And we've got to add the code here that's going to make the button active. In other words, call this action listener whenever it is clicked. Okay, so it's a missing code there. And then we get our main method, which creates an object of type play tester, sets the default close operation to exit on close, sets the size and sets it visible. So pretty standard stuff there. Okay, so it's a missing code there to fill in. And we've got some missing import statements here. Okay, so a bit of a strange question. A lot of reading and not much code. But anyway, that's the question in the practice exam. So let's paste it into ChatGPT and see what it says. Because if you can understand obscure questions like this, you can understand anything. Okay, and we'll paste that in. And we'll go clear, and we'll start a new ChatGPT session. Okay, and it's I can see straight away it's got the exact answer. Okay, so there's some missing imports: java.awt.event.actionEvent and action listener. So these are the classes needed to make this button listener work: action listener and action event. So there's the imports for those. It's Java, not JavaX, because they're AWT components. So it's java.awt. And then down here, activating the button, in other words, making it react to mouse clicks. We add an action listener to that button, and it's just new play listener. That's perfectly okay. So BT is a button name, bt.addActionListener, new play listener. And it even fixed the issue that I talked about above, where we had JButton declared twice, JButton and JButton down here as well. It's fixed that as well, so that's good. It's even fixed up part of the bodgy code that was in the question. Okay, and that's perfect. Again, full marks for that. So question 6, worth 5 marks out of 65. Assume that the following program compiles and runs without any errors. What is the output? So that's the key. That's the key part of the question: is what is the output produced by the program? Okay. The third for loop has to be rewritten using an iterator. The iterator should iterate through the team list object and retrieve data from the team list and display the retrieved data on screen. Okay, so there's 2 parts to the question. There's what's the output, and then rewrite the third loop to use an iterator. Okay, and so pretty basic stuff again. And it's using a basic linked list. So we've got an array there, putting data into a linked list, looping through the array list there, and then using an iterator. Or actually, yeah. So the third loop's going to be rewritten using an iterator. Okay, so pretty basic stuff, really. Although iterators and things were things we covered late in the course. But generating the output for that should be pretty easy for a student. Let's see what ChatGPT can do. Okay, so let's look at the question. So we've got Australia, New Zealand, India, UK, Pakistan, China. And we've got a team list, which is our linked list of strings. We're going to put this data into the linked list. So here we're adding the teams from the array into the linked list, teamlist.add, teams from the array. And then looping through the linked list, through the array list. Temp team equals teamlist.getI. So we're getting each team from the array list. If temp team dot equals New Zealand, remove it from the array list. Okay, that's right. So we're just removing New Zealand from the array list. So we should have Australia, India, UK, Pakistan, China as the output. Australia, India, UK, Pakistan, China. Yep, so New Zealand's gone. That's correct. And now we want to rewrite this third loop to use an iterator object. Let's see what the code's done. Okay, after removing New Zealand from the list, yep, righto. So it's missed that third part. So let's just ask ChatGPT again to do that third part. So we'll just paste that paragraph in again. Okay, so it's provided us the code, and it's created an iterator object of type string. Iterator equals teamlist.iterator. Yep. Yep, so it's created an iterator object based on the team list array list. And then while iterator.hasNext is true, it's getting the data out with iterator.next, printing it out to the screen, and keep looping while iterator.hasNext returns true. That's perfect. Again, full marks for the answer. It missed this on the first go, but I just pasted it in. You probably asking double barrel questions or do a lot of things questions aren't valid for ChatGPT, but certainly when you ask it one at a time, it gets it right. So that's correct. The output is absolutely spot on, even though it's a pretty easy output to generate, to guess. That's just the output from the array list without New Zealand, or with New Zealand removed. And then we've got the iterator there being used to generate the output from the array list. Good stuff. Excellent. Well done. Full marks. Okay, so write a program. Question 7 is worth 5 marks, so 5 marks out of 65. Write a program that uses a stack object to determine whether a string is a palindrome or not. A palindrome is spelled identically backwards and forwards. For example, mum. Normally with palindromes as well, you remove punctuation and spaces and tabs and anything like that. Question marks, exclamation points, all those sort of punctuation characters. Usually the basic A to Z characters there. And uppercase, lowercase doesn't matter either with palindromes. But anyway, it's just asking a basic question there. So let's copy and paste that into ChatGPT and see how it goes. Okay, so we didn't tell it what language, and so we might give it a bit more information there. Write a Java program. Okay, and just give ChatGPT a bit of a help. Write a Java program. Okay, I love the way it's generated some output data. So it's done it for mum, hello, and a man with a planned canal, Panama. Okay. So look, so it's importing the util stack, which is correct. Is palindrome? It's going to return true or false based on the input, which is a string. Clean string equals input string to lowercase, converting it to lowercase. We're creating a stack object, a stack of characters. So stack character stack equals new stack. Okay, fair enough. And for char C in our clean string dot to char array, we're doing stack dot push that character. That's fair enough. I guess we could do that. That's fine. And pop the characters in the stack and compare. So for char C in our clean string to char array, so for all our characters in our string, if C is not equal to stack.pop, then we're going to return false. Okay, so otherwise return true. Okay, so return false if any of those checks fail, or returns true. This code here, I've got to say, is okay. I would probably give it close to full marks in an exam. Two things I don't like about it. First thing, we've got two exit points in the method. I like just having one exit point. So I'd rather set a Boolean is palindrome to false to true here and set is palindrome to false there and then return is palindrome. So rather than have two exit points in the method, just have one exit point. So that would be my first complaint. And the other complaint here is this is very inefficient. We're returning, we're comparing the whole string, all of the characters in the string. Okay. Whereas for palindrome, you only have to compare the first half to the second half. So you start at the back of the string and the front of the string, and just compare character by character, stepping in each time until you get halfway through. And if they all match, you've got a palindrome. Okay, so again, this is okay. Pretty bodgy, pretty not ideal because it's comparing the whole string every time. We only need to compare the front half to the back half and the two exit points. So this question was worth 5 marks. I would probably give the answer 4 marks there in an exam because we've got the loss of efficiency. The loss of efficiency because we're comparing the whole strings and we've got 2 exit points in the method, which isn't ideal. Okay, so 4 marks out of 5. Not an excellent answer, but I'd say a good answer. A good answer, not an excellent. Okay. Although the question didn't ask for it either. In fact, we might add that in and see how it goes. Remove punctuation, white space. Okay, so we're telling it to remove the white space and punctuation. And it's not doing that at all. So it said it was doing it. Sure, here's the updated answer, but it hasn't actually changed anything. So it hasn't. So none of those would. none of those would return us true, those last ones, because then it's not removing spaces or single quotes or exclamation marks or tabs or anything like that. So it failed on that as well. So I'll stick with my original answers because it didn't ask to remove punctuation or white space. But if it had, I'd be giving this answer here 1 out of 5 because it doesn't do any of that. Okay, so yeah, bit of a fail there. Let's do it in the question. Let's see if we can do that. Remove white space and punctuation from the string. We'll paste all that in. We'll start a new conversation, clear conversations, and we'll start with a fresh slate and see how we go. It's still not doing it. Okay, don't care what you say down here. I'm looking for a program, and it's still at the 2 exit points, and it's still not removing punctuation. Oh, hang on, here we go. Replace all. So it's doing a replace all there to remove punctuation and stuff. So, okay, yep, no, I'm happy with that now. Yep, so it's using a regex to do a replace all. That's fine. Yep. Okay, so it is doing it. So I would give this answer here. If the question was worth 5 marks, I'd give this 4 out of 5 again. Because with the 2 exit points here, maybe 4.5 out of 5. Okay, so still a high distinction, just not quite full marks. Okay, so question 8 is again to do with it's to do with trees in a diagram which ChatGPT can't understand yet. So I could do an ASCII representation of this tree, but I'll just leave it for now. I'll leave it for now. Okay, and then question 8, part B. So it's both these parts together with 5 marks out of 65. We could see how it goes to that one, I suppose. But then it's got subscripts and superscripts, which I'm not confident. I could put an N hat 2 there. Yeah. I'm not going to worry. Not going to worry about that one either. And 9 and 8 and 9, or 9 and 10 were extra questions we could fill in the tutes when we're working through past exams with students. So they're not there either. So overall on the sample exam, as incomplete as it is, it's not a full sample exam. It's missing most of part A and at least 2 questions from part B. But based on what the work ChatGPT did, I would give it easily a high distinction and very close to full marks. We're talking 64 out of 65, assuming I got these questions right as well, and the other parts of part A that we hadn't looked at. Okay, but it was definitely heading down HD, high distinction territory. So a big question here for people setting exams and exam conditions is if we allowed students to answer their exams electronically, for example, typing their answers into, an IDE, NetBeans, or TextPad, or Notepad++, or some other tool, so they could compile and test their work to make it more like a real work environment. That opens us up to a whole lot of issues with tools like ChatGPT available. In the old days, if students wanted to cheat on an exam and it was an online exam, they could answer it on a computer with a network. They could have someone else on an MSN chat or something that was they'd copy and paste the question, and that person would work on a question and copy and paste it back, and they'd paste it into their exam attempt, and on they'd go. But now they can just paste it into ChatGPT and be pretty well guaranteed for introductory programming, for this introductory programming course anyway, to get a high distinction. Okay, so if ever we change over to just a sec. So if ever we changed over to non-paper based exams, so they could type exams into a IDE or whatever, we'd have to make sure there was no network ability for the computer device they were using. And even then, it's not guaranteed, because you can now download and install ChatGPT on your local machine, train it up, and have it answer stuff. So, without any programming knowledge at all, I can download ChatGPT, install it on my local machine, and it can work away. So, and if it's not ChatGPT, there's other tools out there. So, powerful stuff, sure. Great promise for the future, absolutely. But there's also issues as well, like helping students cheat on their exams. And that's always been a huge problem at university. Not just cheating on exams, but on assignments as well. We'll have a look at assignments next. Okay. Anyway, thanks for watching. Hope that your video was useful. Have a nice day.